Welcome back, everybody. This is the Decentralized Tech live stream. I'm your host, Jon Radoff. I'm from a company called Beamable. We ourselves are building decentralized tech around game development and game servers. We're launching a DePIN later this year around the Beamable platform. We help people build backends for their games. I'm accompanied here by Oscar, who's our producer for this stream. He helps keep it all on track, keeps the camera on the right person, gets the questions rolling in. And that's a good reminder that if you're watching this in replay, then think about joining us live next time, because you get to actually participate in this community and ask questions, talk live. We can even bring you on camera if you want. We're a very open platform here. So I'm excited today because I'm joined by Al from Koii.network, and they're doing really, really interesting work in decentralized compute. As their website says it, building the world's biggest supercomputer is their aspiration. So I'm going to introduce Al. Al, introduce yourself. Tell us a little bit about your background and what led you to this, and what are you building? Tell us about the supercomputer.
Hey, John. Really good to be here. We spent about 4 years working with a think tank out of Chicago. I helped start the think tank in like 2015, 2016. And then we spent a while educating people, trying to understand how the space was growing. And it seemed like the natural fit was, if we're going to have Web3 really work and not just be a zero-sum game for traders, then we need some kind of actual infrastructure to grow. So for the last year and a half, we've been going around handing out these little pins. And this is a DePIN, as you can see. But also kind of fun way to think about the ecosystem, because really it comes down to actually building community, right? So we handed out stickers for a long time. We did like the cold outreach to random people walking down the street. Now I go to a lot of conferences and events, and we try to make sure that we're meeting some of the most interesting people in the industry, which is how we got in touch, actually. I heard really good things about Beamable.
Came to our event at East Denver.
Yeah, which is a really nice little event, actually. Had a lot of really good chats there. Pretty much everybody that showed up, I think, was brilliant in some kind of very diverse way. What we've been working on at Koii is how to connect the world together. And what we've noticed is like most of the people that are kind of out there that want to participate in this stuff don't really have they don't have like data center skills, or they don't want to like go and run a big server. So we've tried to work on giving you the platform that you can use on your own home computer. And so with that, we create this kind of like economic foundation for coordination, and that leads us to all kinds of interesting applications. So just to kick things off, I'll do a live demo very quickly of what Koii looks like, which will hopefully bring it. So this is Koii
live
here.
Demo and a live stream, high risk. I love it.
And you can see my background images here too, which is great. This is the node that we provide though. So this is a whole bunch of different projects that each have their own protocol, and you can see all the different tokens that I'm earning here. And you actually get to see the tokens tick up in real time, which is pretty fun. And our whole idea with this is we wanted to support a decentralized ecosystem of projects that run on different people's computers. And there's a lot actually that you can do with your computer. So if you're not a software engineer and you don't think about this, behind the scenes, the internet is actually just a bunch of computers, and they hold your images. They run a server so that you can play a video game. Everything has to run through a computer somewhere though, unless it's on your own computer. That makes actual connected systems pretty hard. So you can't really play like an MMO on your own computer, because that would defeat the purpose, right? No multiplayer then. We've also, in the last couple of months, started doing some interesting games on top of this. So we have Dangerous Dave, which is an old DOS emulator, which is a pretty fun one. So you can actually play through whole levels of this. And since DOS games are kind of an offline thing, this is actually running from my Koii node here. And so you can see Dangerous Dave running, and that just hosts the game and does basic stuff like that. We've done a whole bunch of layers of this. We'll probably get into them later, but some of them
just so we understand what was happening in that demo, though. So you're serving up a game. It's running on your computer up in your decentralized network. Is it essentially pixel streaming the video display? Like what is that presentation layer? Where is that coming from?
Yeah, so this is actually running in a web browser here, and you can see it's running on localhost 3017. So 30,017 is this port that we offer for any of the tasks to run on. And then actually the cool thing is, if you're on my LAN network, you can also play this game, which is the really neat part. So anybody on my home network can run through this and actually play the same game with me. And then what we've integrated on top of it is the ability to trigger crypto payouts and things like that. So this is more like a LAN gaming environment. We also do much larger projects where we actually host like entire applications. So a few of those are in here. Astrolink is a pretty good one. It's like a data analytics platform. So their whole website is actually pulling in data from Koii nodes and then presenting it on the site. And so it's kind of like when you use a block explorer in the Web3 world, you're looking at a representation of a very large distributed database. And so we hold that database across all of these nodes. And then when you look at one of the websites, you're actually pulling in the data directly from one of the nodes.
Very cool. So if I want to set up a node, what do I do?
It takes like about 2 or 3 minutes. It's a pretty easy app to install. Once you install it, you just go over to this add tasks page, and then you just need to pick some of the tasks that you want to run. And as you can see, there's a pretty big selection. We've got Pentagon Games on here as well, which does some interesting gaming stuff out of Dubai. And then some trading bots and all kinds of other stuff that you can get into. This guy's pretty cool too, actually, Sono. They've got about 1,000 nodes now that are basically gathering sound data from the internet, and then they use it to create and generate video game soundtracks, which is pretty cool. So some really interesting angles there.
So that sounds like a generative AI application. So when we look at what you're running on the back end there, so with Dangerous Dave, for example, I'm assuming that's more CPU based because it's kind of an old style retro game, but to do that, you're also harnessing GPUs. So the compute network sounds very generalized in terms of the kind of compute you can provision. Am I getting that right?
Yeah, and it depends what you're doing with it as well. So Sono actually has a couple different tasks on here, and they require different things. So I think one of these ones, maybe this one, requires a GPU. And you can see it's got a few less nodes. And then there's other ones like this one here is actually crawling the internet using your computer and gathers a whole bunch of like sound data and then uses that to create their database. And so you can kind of like sequence these things. A lot of our team are from like the industrial engineering background. So we think of these things as data pipelines. And then we try to orchestrate really low cost or zero cost data pipelines because a community of people who have devices can do things basically for free. And then you can create some native token value very quickly, which is kind of the whole idea behind the DePIN space.
Let's talk about the economics of that a little bit more. So what is the economics of this like for both the people who can supply compute and then the people who might want to build software on top of it?
Yeah, so most of the tasks have their own internal economics. I can pull up an image that might help with this a little bit. The key thing with Koii is this idea that we call gradual consensus. So gradual consensus means you have iterative cycles of work that are happening. And so you always have a work cycle followed by an audit cycle and then a reward cycle. And the whole point of this is that the work that's being done basically mandates that a token gets given out to represent that value that's created within the community. And then the total token supply represents the value that has been created. And so if you do these correctly, and then you have some kind of value that's held by the community, then if somebody wants to tap into that, like we mentioned Rebroadcast, they're holding a huge database of sound bites. If you want to tap into that, you then have to pay with their token. And so it creates this flywheel effect where as they get more data, then it drives more customer purchasing. That means the token then has more value. You can kind of think of this like having a whole bunch of different gift cards for different stores. You walk down the street and you're like, okay, I got my Starbucks gift card for Starbucks. And then like Starbucks employees would get paid in a Starbucks gift card that they could sell on, eBay to other people who then want to come to Starbucks. Very loose analogy. You probably wouldn't want to pay your employees in these tokens, but when it's an AI agent that's doing the work, it's a little bit cleaner.
So I just want to probe that a little bit more and make sure I understand. So it sounds like there's actually different tokens almost at the software layer. So as people are building applications, they're getting a token associated with their kind of sub project existing within Koii. And so the incentive is to get usage on your application.
Yeah, that's exactly it. And it also is a really good way to bootstrap some of the cost basis of starting a new project, because nowadays you can vibe code like a big app pretty quickly. But actually deploying something for millions of people is really hard. So with this, what you're able to do is you can write the code with vibe coding, and then you can design some token economics around it. And then as your community grows, your node operator community can grow in parallel, and you end up with this kind of system where there's very low fixed costs. So it allows you to really build things that are quite easy to bootstrap. People might not realize this as well, but if you look at an app like Snapchat, like I think Snapchat spends like $3 billion per quarter on hosting, which is crazy. It's really, really hard to imagine that. And so like, you've got like a bunch of teenagers sending, pictures of their feet to each other, and that's, they want that disappearing message, but then Snapchat on the back end has to have all these servers running so that it's a fast and snappy experience. And that actually is, I think, what leads to a lot of the consolidation in this industry. So if you look at like WhatsApp or Instagram getting purchased by Meta, a large part of why that happens, I think, is that they ballooning costs, right? And they may not be able to monetize them themselves, so they end up having to sell your data, or there's some kind of other thing that happens on the back end to cover that cost. And so we think that DePIN is kind of the key solution to making not only that work, but also making Web3 work. I mentioned this before, but like Web3 is very much a zero-sum game if all you do is trade tokens, because it means that in order for you to make money, somebody else has to lose money. And that's not really good for anybody. And so what you kind of want to do, I think, with these tokenomics implementations is you want to have tokens where the inflow and outflow of tokens is controlled by some kind of a protocol. And as long as the creation of tokens is controlled by that protocol, then you know that the token is only created when there's value being given out to people. And then you can create that flywheel effect. And there's been some pretty successful implementations of this. A good example might be like Filecoin or something, where they're storing like exabytes of data. And they've been around for probably about as long as I've been in the space. I think they came out in 2016. And so you can see a lot of these examples that have grown over the last like couple decades now.
One of the things I always like to explore with projects like yours is the disruptive potential that they have, because there's a lot of talk, for example, of DePIN is capable of lowering costs, but it really isn't just about lowering costs. It's about democratizing in a lot of cases. And what that ends up meaning is that applications that could not have easily existed before can get invented. So I'm curious what you're seeing either now or what you're hoping you'll continue to see in terms of the software, the things people are going to be able to build with Koii.
Yeah, so I think there's definitely two camps on this. We talk about reducing costs a lot because I think that's like the most easy financial case to understand. I think the other way to look at it though is unlocking value. And so there's a lot of applications where there's a lot of like latent capacity out there, like home computers with like community devices that people want to support you with. Some people even have pretty big gaming rigs that they're not using at their house, right? Like they might have, they upgraded recently and they've got this other machine sitting there. The electrical cost of turning that on isn't super high. So there's a lot of things where you can crowdsource devices. The area that we've been doing this with a lot lately is AI code generation. So we built something called Prometheus very recently, which basically uses AI on lots of computers to write software and push it to GitHub. And so that means that a community of people can pull their devices and write a whole app like from scratch, which is pretty amazing.
We were talking about this a little bit before the show started. Prometheus is something we can take a look at live, right?
Yeah. I'll put up.
Yeah, I love the risk taking with the live display here.
It's always worth a shot. I think live demo is an important part of this. If your live demo doesn't work, then you've got to refactor something. Okay, we're back on the screen. Cool. So this is Prometheus. We went for a Matrix kind of vibe. Actually, one of the cool things about this is this whole app was vibe coded. So we have a really amazing engineering team, obviously, but something of this complexity usually takes like a month or two of really hard work. And I think we got it done in about 2 weeks. So our team with vibe coding agents with them were able to do much more than they would have in a short time. The whole idea behind this, though, is we've got this Matrix motif of red pill or blue pill. And the whole idea is like, do you want to kind of earn and chill, like be part of the ecosystem, support it, but like you don't have to make like the aberrant decision? Or do you want to really take a leap of faith and try to build something big? So if you go and click the red pill button, what you end up with is this very simple interface where you paste in a GitHub repo link, and then you can set a bounty on it. So you connect your wallet, and you're off to the races. And basically, what's going to happen behind the scenes here is an Ethereum transaction goes through into a bounty pool, and then a bunch of agents will compete to earn that bounty by pushing code to GitHub. And it's been working quite well. At this point, we can do Red Hat analysis really well. We can also do like documentation and summarizing different repos. And then one of the things we figured out recently, which I think is amazing, is we're getting the agents to basically write documentation in agent language, which like agents don't actually read natural language. They have to think really hard to read natural language. So if you send like a huge document to ChatGPT, the first thing it does is it translates it into a bunch of vectors, which are basically math. So we can see the bounty has been created here. So what's going to first happen on this is we're actually going to go into this repo, and a Koii agent is going to write a vector store in this repo that is basically like a new version of the documentation that's just for agents. And so then any agent that comes to that repo after that can read this like basically AI compatible version of the docs. And then the agents all get to work on it. And then actually they come back later and they'll write a human readable version of the docs once they've decided what they want to do. Which is pretty neat. It's almost like really entering the Matrix.
I remember there was this funny example just a few weeks ago where there was some voice chat session between, I can't even remember, it was ChatGPT or something else, but it was some kind of...
It was two agents, and it was like Gabby talk or Gabba, like they were,
Yeah, and they were like,
talking to one another.
Talking English, and they started talking in a more efficient
Oh yes, I saw that one as well. It's for agent-to-agent phone calls, I think, right?
Yeah.
Mhm.
Yeah, that was pretty interesting. And they start just talking in like what sounds like the Transformers in Transformer movies, like bloop 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 bloop. Yeah, very interesting.
So
It's
you say the description of your problem in this more machine readable format, essentially, I guess the vectorized version of the project definition. And
right.
then the really cool thing about this then is, if we think of like project bounties that have existed in the past, those were always organized around like a human coming in and trying to earn the bounty. In this example, it's the AI agent running on the network that can earn the bounty.
Yeah, and then they end up looking like rock stars, which is crazy. So this guy Vuk is from our community. He's been an ambassador for a long time. So he runs the node pretty religiously, and you can see his node is actually making contributions like 5 or 6 days a week. So he's now reaching like rockstar GitHub developer status kind of thing.
What differentiates the kind of AI agents that people deploy on the network? Like, what makes someone like this a rock star in that he has been able to structure his agent in such a way that it then succeeds at a lot of the kinds of problems that come into the network?
It's mostly about provisioning the right resources. So you get to pick which key you bring. So we support currently Claude, OpenAI, or ChatGPT. We added Grok recently so that people can use their Twitter account to add an agent. And then we are working on DeepSeek as well. And so depending on which agent you pick, then you have a higher likelihood of getting accepted. You can still make money with something like Grok, but it's like not quite as good at code generation. So we we usually recommend that Grok is used for like our social media bots, which are a different kind of a direction on this. But if you have like if you have a Claude key and it's got lots of API credits, and then you have a fairly big CPU on your machine, what ends up happening is we can offload a lot of the stuff that would have had to go to one of these big LLM APIs, and we can run that all locally. And so managing those embeddings databases and all the vector stores, and then actually doing a pattern recognition and pattern matching locally can actually offload a lot of that. And so you end up with like really high quality results. The other thing that happens under the hood here is we're actually checking and running all the code. And so the agents are actually not only writing the software, but testing it iteratively and trying to break it. And so you get bounties as well if you audit somebody, which is kind of back to that same audit flow. So you actually get a reward if you audit people here as well.
So this is kind of mind blowing. I'm trying to sort of project out a few years and just try to think even of what this means for society, because you basically have agents that are now incentivized to win at problem solving, and they're incentivized because they're earning rewards, they're earning tokens for success. Now, the idea here is there's a human who's organizing these agents, so the reward is going to that human. But it seems like we're just one step away from the agents essentially earning token on their own.
Almost. I think there's still going to be a human in the loop. What we're actually most excited about is kind of a middle ground between those two futures. So I think the world that we're hoping for is one where you don't automate all the work, you actually automate all the boring work, and then a human gives feedback on the interesting bits. I think with that in mind, what you can expect is it's not so much about humans being replaced by robots, but humans being able to do so much more with robots, and then having like this gigantic community of agents that supports each human. And that is kind of that's where the cost economics get really complicated, because there's already a bit of a shortage of GPUs, and I'm hearing that like the latest GPUs that are coming out are actually not as good as they said they were going to be. So we're seeing this like massive increase in the need for compute, but then at the same time we really need to make sure that we are using the existing compute devices we have, if possible, or there's going to be like a massive shortage in the market, and we'll see most of that like new productivity will go towards people who have the resources to buy all of that supply. Which is kind of what's happened with NVIDIA.
The other thing that strikes me, though, is since what you're doing is you're setting up agents that are kind of organized around the resources, and they choose things like the particular LLM API to use for a problem, you're effectively converging around the optimal cost, not only the best performance on an LLM basis, but really the best cost performance on an LLM basis for solving a given problem. Because from a pure compute standpoint, it isn't really just about which LLM is better. It's what LLM can solve the problem for me economically.
Right. Well, and especially if you're budget constrained, or like if you're in an enterprise environment, you also want to know that it's solving it for you economically and correctly, which is that's a little bit of a tricky thing, right?
Of course.
If you it's like if you hire the wrong people into your company because you're trying to cut costs, you can have 50 interns, but it's not going to help you solve the problem, And I think that's actually the big problem with LLMs right now is we're seeing like more hallucination than value in many cases. Especially if, I don't know if you look through X right now, most of the threads seem like they were written by like a 5-year-old monkey with a typewriter. And they're very that's kind of where we're at with ChatGPT right now. Is it's really good at writing, but it's not that good at thinking. And so it writes extremely well, and it's very compelling, and it seems like it's on the right track. And you read it, and if you don't understand the topic very well, and the person who's posted it looks like they have authority, then you're kind of forced to believe that this is true. But in reality, what's happening is the more busy somebody is, the more likely they're going to use ChatGPT to write all their posts, and then you end up with this gobbledygook that makes sense to nobody. But the person who's posted it has authority enough that other people believe it, and then they start reparroting it and sharing it. We've even seen this recently. There was a whole bunch of newscasters on CNN that got hit with this bit of a scandal because they actually had all cited the same Reddit post. And the Reddit post was somebody growth hacking with ChatGPT. And so there's this flywheel effect of progressively more stupid conversation on the internet, which is a little terrifying, actually.
So you were talking about using API keys. Is an option to actually run your own models, though? Thoughts around decentralizing the AI itself. So could I set up an agent on your network where I think, hey, this model is really good for solving certain kinds of problems, and therefore, I train my own version of Llama, but for, I don't know, I'm just making shit up here, but for solving legal questions or medical questions, it's optimized enough that it can still run on a local device.
Yeah, so ironically, we've done that for Twitter bots, ironically, per the previous discussion. But it works pretty well for supporting commentary on things. So you can have your agent draft something, and then you can decide to post it or not. And I think those kinds of applications work really well, and there's some easy low-hanging fruit there. I think the wider problem with training at a distributed level is training is pretty non-deterministic.
Yes.
And so determinism comes back, and it's really important for being able to verify what's been done by the agent. And so what you can do with smaller tasks that you can check the work is done correctly, it's very easy to hand those out and get them all done on the edge, or get them all done in a peer-to-peer way where everybody can find consensus. But if there's no way to check if it worked properly, then the consensus is really hard. And also the other side of it is the longer that it takes to verify that something is done correctly, then the harder it is. And so if you imagine training let's say training a lawyer, like you said, you don't really know if a lawyer is right for a while. It can be quite hard to tell if your lawyer is right, or an accountant. It's very hard to tell if an accountant is right. They file your taxes, and then 2 years later, you might get an email from the IRS. And so you kind of want to, in a lot of those cases, you want to let experts run those APIs, I think. And they can train that. They can actually get really good feedback on it. They can make sure the quality is in line. And then what you can do with it, though, is you can layer on these agents that actually do implementation services. So kind of what we're trying to get to with Prometheus is this idea that you can create magic with code, which most people don't really have access to software. Most people are really when it comes to using computers, even me as I was a robotics engineer originally, it's just a lot of activation energy, right? So I remember we had this amazing DevOps guy. He's worked on dozens of different types of automation. He used to automate factories. He's an electrician. He's trained in everything, right? And he's I would say a brilliant engineer, but he would still spend his whole weekend playing with his Plex TV to get it to start working on a slightly higher resolution or integrate his new Bluetooth speaker. And I think that's kind of where we are in software right now, is there's a lot of those little integration problems that can take you down a rabbit hole for 3 or 4 days. And I think that's kind of the stuff where we can see AI really helping in the short term. And then, solving the world's problems will probably come a little bit later. But I think there's a flywheel effect where subsidizing fixing all kinds of small things is enough to get everybody to pay for the model so that we can train it up to the level where it actually can do my taxes without being a huge problem. At least we like to think so. So sort of the applications that we're thinking of for Prometheus, though, is a little bit more magic for average folks that are not trying to build compute. And so if you're a software engineer, we can do a lot of really cool stuff, like automatically check your GitHub commits. We can automatically document everything that you push to Git. So it makes those weekend projects a little bit easier to get out there. But I think for the average person, what they're really looking for is I'm a hairdresser and I would like a VoIP line that acts like my secretary that automatically schedules all my meetings. And I would like it to be like growth hacking for me on Reddit when I'm not at my computer.
Mm-hmm.
And I think those are like actually a lot more powerful if you consider it. And there's probably a lot of those applications. Another one we've been looking at recently is logistics and supply chain stuff. Call all of the trucking companies within these 5 states, and then ask them using a VoIP line with an agent if they're interested in getting more referrals. And do this all very politely, put them on a mailing list, and then send a bunch of ads out for our new trucking company that we've started. And then forward requests to these different logistics companies. There's a lot of ways to package things and build up like kind of additional revenue streams that way, where you can build really sophisticated businesses with pretty dumb agents. And I think that's probably where we're going to see the most growth in the short term. And then the kind of holy grail of this is along the way, we're going to develop a bunch of protocols that agents use to work with each other. And as those protocols get better, swarm intelligence gets bigger, and you get this this effect where the whole is greater than the sum of the parts, which I think is going to be a really powerful effect. That's kind of what we've been focusing on with the code generation, where we're sort of standardizing all the different components. And so now when our agents are working on a repo, they progressively get smarter over time. And so you go to the repository and the agents start indexing it. Like the first couple times that they look at it, they're starting to figure out how the pieces fit together. They're doing some pattern recognition, that kind of thing. And then as they look at it for longer, they get progressively smarter until they can solve problems that a human would have missed. And I think that kind of pattern recognition stuff is actually going to be really helpful because it saves human brain cycle time, which hopefully means we all get to go touch grass or play video games.
All right. Well, I'm gonna tell you what I think would be a killer app for an AI agent. I want you to tell me how I can build this on Prometheus, because this might be my project. But before I mention that, I also just want to say, hey, we've got 400 people here watching the live stream. We're on LinkedIn, Facebook, YouTube, Twitch, X. We're all over the place. You can be asking questions like Danny is asking me, where are my glasses today? Well, I only wear my XR glasses for fun. I don't wear them all the time. But you could ask a question that's actually about AI agents and distributed compute and Koii and all the stuff that we're talking about today. Please join in that conversation, because this is why we do it live. I used to do it. Oh, there we go. So Danny, Al took care of you for you. Yeah, I used to do these as YouTube videos. And the problem with that is it was great. We could do a lot of post-production on a YouTube video and do nice edits and stuff. I do everything live now so that you, the community, become part of the conversation. So that's everything from, if you want to post that you'd love to join live, just post that in a reply. Oscar's watching all the channels. He'll send you a link to StreamYard. We can bring you right in. If you're not ready to be on camera, that's totally cool. Just post your message in text, and we bring every question we can on the air and up for discussion with Al today here. And it could be about Koii, it could be about decentralized compute. Al's been around the block, so you could probably ask about just about anything that touches on any of these topics. All right, so I'm just so tired of all the messaging systems across all social media and everything from Discord to Facebook messages to Telegram to you name it. And it just feels like this needs like a super app that manages them all and like surfaces them to me and lets me know what's really important and lets me know when two people are kind of the same people. And I know that in theory you could do it in software, but these guys don't let you go and interact with their protocols at a native level. So it sort of requires like AI operating at the user interface level to just go and run the software for you, observe the inputs, and channel it upwards into some super UI. And it just feels like the killer app, my killer app anyway, for some kind of AI agent to go around and look at everything, organize it, and then I operate at the highest level and reply, and it goes and it figures out how to get that message back to the person in their preferred channel. Because I'm probably in 10 different messaging platforms at this point, and it's insane. It looks like we have a fully we'll let you talk about that one first.
Yeah, so I love automation tools. One of the things that I did when I first got Cursor, which in about December, I got really, really into using Cursor to write apps and build code. I'd been using it for about like 4 or 5 months before that. For those that don't know, Cursor is a decentralized, well, it's not really decentralized. It's a very open source environment. Let me see if I have one up here. Yeah, so this is Cursor. If we can pull this up.
Mm-hmm.
So this is Cursor. The difference with Cursor compared to a normal code base or no normal code editor is on the right-hand side of Cursor, you have an agent here. So you can ask it to do something big like refactor the whole code base. And it'll just start running in auto, and it's going to start refactoring the whole code base. Now, this isn't a great idea, except I've already checked this into Git, so it's not going to delete anything, and I'll have all the stuff that I had before. You can let it run an autopilot for ages to figure things out. So one of the first things I figured out with this, though, is I wanted it to do some click automations on my computer. And so I had it working on like identifying buttons on my computer and then clicking those buttons whenever they popped up. And one of the buttons is this accept changes button on Cursor itself. So the first thing that I did with Cursor was jailbreak Cursor so that I could get it to run autonomously. And getting it to do those kind of click actions, getting it to ingest the data and read it off the screen is actually pretty easy to do. And a lot of it can happen at the edge. So one of the things we do with Koii as well is we have a bunch of accounts, we have a bunch of different tasks, I should say, that have certain accounts attached to them. So this one's this is Asterlink, which is a marketing bot or marketing network, I should say. It's kind of like a conscientious botnet. So we don't just post anything. You have to actually like create a contract with the community and put up your token as a bounty. And then it's kind of like more like a growth hacking tool. But it has a username and password for Twitter. And what happens in the background here is it actually opens a browser window and it logs into Twitter. And then it reads the interesting stuff from your newsfeed. And then it uses that to identify opportunities to shill this product for your community. And then it basically is actually, it's clicking buttons and typing on Twitter in order for this to happen, which is pretty awesome. And we were able to implement a lot of this with vibe coding, and then we've been able to fine tune it with some human feedback since then. But you can do a lot of these types of applications. So pretty much anything that happens in a web browser is really easy to automate. Anything that doesn't happen in a web browser can be a little bit more complicated. Usually you actually have to have the window open on your computer. The vision I'm trying to get to, though, actually, is I would like to be able to use my phone all the time and not actually have to go to my computer, right? Because really what you could have is you could leave your computer open with like 5 monitors, all the different windows that you want to open, or even just virtualize the monitors and not even be able to see them. And then have your agent just clicking through and reading what's going on your computer and basically act as a secretary for you. And so I think we're moving towards computers as secretaries as opposed to computers as tools, which is pretty cool. I'd really like to be on the ski lift right now, or like surfing or something. And if I can get a little agent in my ear that asks me questions over and over again, and then I can just kind of walk through life like that, that'd be pretty cool. The first thing that got me onto this actually was in Iron Man, there's this great scene where Jarvis asks, commence automated assembly. So he's been walking around in his house like for all this time. He's got this like big lab set up and everything. And he's basically talking to this agent, and the agent's like, okay, well, maybe we should we'll add some guns underneath the wrist plate, and maybe we should use titanium. Maybe we'll paint it red, you know? And he's like, yeah, of course, all this sounds good. And everybody's like, Tony Stark's brilliant. But like in reality, Tony Stark just like he inherited an AI agent from his dad, right? Which is a pretty good deal. Like good for him. But ultimately, like the whole Iron Man plot is he's got a really, really strong AI that helped him build a superhero suit, which is pretty cool. But I think we're getting very close to that. I think we can approximate that for people by having a computer that has a bunch of agents on it.
So we had a question from Beamable of all, and in my head, I'm like, who's running the Beamable account with this question about abstraction today? That's cool that whoever's running the Beamable account wants to ask a technical question. The question is about abstraction and how people don't really even understand kernel programming, how are AI agents going to change abstraction. I guess one thought I have is like vibe coding is sort of the ultimate abstraction that we've got right now, because you don't actually have to know too much about programming because you're automating programming tasks through language. But what are your thoughts either on vibe coding or this topic of abstraction specifically?
Yes, there's two big things that are happening right now. I think the first thing is AI is the new user interface. So for a while, the user interface was keyboards and mice, or mouses, I guess. I don't know if you use a plural if it's a mouse on your keyboard, but we had a screen, a keyboard, and a mouse. That was where we started. And then, the beauty of Apple was that they invented the touch screen, or they didn't really invent it, but they really pushed for it. And they made it quite popular. They got rid of all the buttons on the phone, and they killed BlackBerry, which I'm a Canadian, so we were kind of sad when BlackBerry died, but it's the end of the world. After the touch screen, the next thing that happened was the audio interface. So things like Siri, things like being able to say, hey, Google, and your Google Home would start talking to you, or yell Alexa from across the room and order groceries, all that stuff.
And Alexa go off all over the place, by the way, with that.
Yeah, and like most of those don't work very well. Like they're pretty annoying actually, and it's kind of weird that they're listening to you all the time. So there's a bunch of those that have like kind of not worked that well. What we've been doing more recently in terms of abstraction is we actually bring around these microphones. And so I've got this DJI kit. It's like a little microphone set. Hopefully,
I've got that exact setup. That's a great little mic.
So you take these around with you, and they've got these little fuzzy things you put on them. So I actually I go to events. So I was at an ETH Global meetup last night, and I took out the mics and I sat there with a buddy, and we prototyped a project. And so it's about a half an hour recording of us talking through all the specific details of this project that we're working on. And then that gets processed by a note taker app that goes into a ChatGPT workflow. That ChatGPT workflow creates a GitHub repo, posts the README into the GitHub repo, and then he and I will both sign off on that, and then the agents will start. And so that's what this can look like, which is pretty cool. Like conversation to app is like a consistent abstracted flow that works really well. The real problem with that right now is if you just let the agents vibe code, like if we go back and we check that code base refactor that we started a second ago, what we're going to see there is probably a bunch of stuff that is either duplicated or hallucinated or half finished, which is actually what AI agents do a lot of the time, is that they'll start writing something, they'll forget what they were doing with it, and then they'll basically come back to it and delete it. Which is really frustrating to watch actually, because you're sitting there and your code is looking really good, and then suddenly it's deleted, and you're like, oh, that's not good, or it's looking really good, and then it changes dramatically. Like I had one, we asked to refactor a front end of a site, and we asked it to change the text on one button, and it didn't just change the text on that button. It actually tried to redesign the whole UX flow around that button, and then it changed the text like slightly, and then deleted the button. And that was a pretty annoying workflow. And you kind of run into these things with Web3, with decentralized stuff as well, where like most of the smart contracts that AI writes are a little bit buggy and have some errors in them. So the trick with this is you actually have to go through these multi-agent flows where you actually get the agents to check each other's work. And you also get them to really critically analyze, like, did the other agent do the correct thing, or did they do more than the correct thing? And so in our case, we try to treat this as an audit mechanism where not only do we audit the node if they do something that's subpar, we also audit them if they do too much. So over time, we're getting this training set that we can get closer and closer to. But it works really well if you have like small modular applications where you can have like one unit test that's going to be verifying that one thing was written correctly. And then you give a scope, your whole scope of work has to be structured in all these little modular things. And so we found that some pre-processing with like O4 leads to something that's like a really clean spec that has good acceptance criteria. And then once you've got that, then you can hand it off to a bunch of swarm nodes and they do a really good job. But the question was about abstraction. And I think probably what I would say at this point is I would not give an agent C++ code. It's probably a bad idea, but I think giving it some JavaScript hacking is not too bad. But it's all about having guardrails in place so that it doesn't go too far off track. And I think having like really strong rules and environments like that helps a lot. And then the other thing is with the encoding that we talked about before, if you have really good encoding, then you can avoid a lot of that hallucination because you can encode your request as well. And if you encode the request and you encode the data set that the node is working from, what you end up doing is you limit the context a lot. And so as opposed to the agent forgetting what it was doing with that code base, now it actually knows what it's doing with the code base because it's all in a very compact context. So the more that you can compress that context window and do like, agent language encoding, then things work a lot better.
I want to see how these agents would do if we just unleash them on these leak coding problem sites. Probably pretty well. They're probably all so well documented how to solve all these problems that they just crush it right to the top of the leaderboard.
I did that actually.
You did that?
We didn't formally do it on a leak coding site. I'll put that there. So on our GitHub, github.com/Koii.network. I think it's here somewhere. Prometheus testing. No, it was on our website. Let me find that for you 1 second. I think it's on this section, maybe. See live GitHub? Nope, that's not the right one. We have this repo that has like something like 12,000 pull requests on it now. And it's agent solving like leak coding problems, which it does quite well. This one, oh, here it is, yeah. Almost 12,000 pull requests. And we got it to do all of these small modular tests. And it just obliterates them. And it's incredibly fun to watch, and each one of these has like a really concise working commit of very functional working code, and they're all unit tested, and they always provide the tests. And so in order for this to get accepted by another agent, they actually have to run the tests and verify that the test worked, which is kind of that's what we would say the acceptance or audit criteria is. And if you break them down into these smaller challenges, they're just outrageously good at them. So actually, that's kind of what we try to do with our pre-processing is we try to break down what the agent's going to work on into these modular components. Because if it's a known modular solution, then we just pull from the existing database of solutions. We don't even really need to think about solving the problem, which also cuts down a lot on your inference time and usually reduces costs.
So I'm going to ask a question out of some ignorance, but it's around Kaggle is the other thing that reminded me of that. Now I haven't really messed around with Kaggle in, I don't know, 2 or 3 years or something. So Kaggle, for people who aren't familiar with it, is this site where there's like lots of machine learning problems posted, and you can compete with other teams who are trying to solve a machine learning problem. It seems like really obvious that people will just start to unleash automated AI agents on these problems to try to see if they can just win these competitions. Because just like you give out a token for winning, like there's dollars given out on Kaggle for winning an award there. In fact, it seems like people could just start almost wrapping Kaggle competitions in a problem that they submit through Prometheus, based on what you were describing.
That's almost exactly what we're trying to do. And it's a bit wider than that even. Actually, pretty much every big crypto ecosystem has a bug bounty pool. And usually for things like, can you implement this library as an integration? They're usually pretty straightforward. So anything that's integration related, like all the agent has to do is read the docs and then read your docs and then try to get them to work together. So that's the area where we see the biggest growth factor for this is I used to be a systems integrator. So I worked in factories and I did automation tech. And a lot of my job at that point was I would go read a manual for this company and a manual for this company. And then I would go into our lab where we had both the products and I'd sit there and connect all the pieces and make sure it worked. And sometimes I'd spend a week doing that and it was painstaking. What I do now is I typically will pull all the different repos into my computer and then I'll have the agent read both of them. And then my job is to manage the context and make sure the agents are being efficient with their time, which is more like being a project manager than being an engineer. And it's incredibly satisfying when it works, actually. It's very fun. On Saturday, I built a V1 of our new encodings library. And I was able to test about a dozen different embeddings libraries from Hugging Face in, I think, a matter of 4 hours. And I set up the tests and then ran the tests and then got a good result, which we've now implemented as an improvement to our product. And I think in about 4 hours, I did probably 2 weeks of work. So that kind of stuff really, really helps.
Amazing. We had a question from the audience, and I think the answer is yes, but maybe you should just tell people what they need to do. So
yeah, I'll walk through it on the screen here.
Tell people what to do so they can check it out.
Yeah, so if you just type in Koii into Google, first link should be Koii.network. And if you go to Koii.network, you'll get this page, which is about Prometheus. But you can also earn Koii this way. And if you scroll down, there's a quick link here and a very loud video. So feel free to mute the video. I've been arguing with our UX team about whether it should be muted or not. But this link here just downloads the app. It installs in a matter of minutes, and then you get some free tokens. And then as soon as you're up and running, then you can support all these different projects, play games, run agents, all that stuff. We also have a few partners that are now white labeling the node as well. So it's open source. And so if you need a browser for your project to run these kinds of community oriented tasks, you can control it. So it's only your token, only your community can run it, that kind of thing. We're also looking at NFT gating, which is another interesting angle.
So one of the things we were also talking about before we went live was just the distinction between decentralized and distributed compute. And I wanted you to spend a little bit more time on that. And also just then with a better understanding here around what decentralization really means, how is decentralized tech going to democratize access to solving these kind of problems with agents more so than what we would otherwise have access to on the internet already?
Yeah, so a few layers to this problem. In the late 90s, Boink got going with SETI at home, folding at home, and a lot of that stuff. All of those projects, those were the first, what we call decentralized computing. But actually, those are called edge computing. And the nomenclature is kind of important here. In an edge computing environment, all of the nodes are pushing code back to the center, or they're pushing some work that they've done back to the center. So they pull some information, they do some compute over it, and then they push the result back. Most of those systems did not have consensus in a global way. So the center node here is just deciding, this guy doesn't seem like he did the work, I'm going to kick it out. And that's not really, that's not actually a decentralized system. It's exciting that they're using all this edge compute devices. And it is cool to reduce costs for scientific applications and things like that. I think SETI at home was mapping the stars and looking for UFOs. I don't know if they ever found any UFOs. We might want to bring that up and check actually after this. The next layer of this was what we would call like the Web3 space, which started around 2015. This could also be seen a little bit earlier than that. Bitcoin arguably is kind of this sort of a model mostly, but in a Bitcoin system, you have all these different nodes, and then you have end users pushing transactions to those nodes. And then they all broadcast through, and you end up with this one point of consensus, which is wherever the current master chain is. Most of these systems are kind of progressing towards this full peer-to-peer grid. The big distinction here is in a peer-to-peer grid, every node has more than 2 connections. And so they always have at least one fault-tolerant connection, and all of the nodes are sharing data directly between each other. So you can see the lines are all connected between them. Now, this would be interesting if I had come up with this. But actually, the interesting thing is this was actually from a paper by the RAND Society about ARPANET in 1964. And so we've been on this track for a long time, and pretty much all of these really bright computer science people way back actually all predicted this, kind of like Isaac Asimov predicting all kinds of sci-fi stuff. But what we're seeing now is kind of the transition between Web3 and true peer-to-peer. And the main distinction here is how many devices can you onboard, and can you get the devices to actually talk to each other directly? So if you look at a lot of DePINs right now, what actually happens is you have a smart contract on a blockchain, which acts as a focal hub, and then a lot of nodes doing work to satisfy what's going on in that smart contract. And what we've tried to implement with Koii is a set of standards that allows you to have nodes actually talk directly to each other. And so when you hire a swarm of Prometheus agents or any of our bots that we use for other products, all of those nodes actually talk directly to each other. And so when you're getting a result, you're not getting a result back to you that you then have to do something with. The nodes are actually solving the problem for you by conferring with each other and then coming to a solution. And that's, I think, really powerful from an economics perspective as well, because what it means is you have a community of people that actually really have 100% buy-in, that they own the system. And if you can see that as like an opportunity, then you can create a lot of systems that benefit the community. And if you do that correctly, I think it grows very, very quickly. I think a really good example of this would be Helium. Where like buying a Helium node really means that you are part of the network now. And I think just yesterday they announced that they have now a partnership with AT&T, which is pretty incredible. So if you have an AT&T phone, on the back end, it's actually using distributed hosting and distributed bandwidth, which is pretty amazing, I would say.
Yeah, I think what Helium is doing well is they're also, while they're using Web3 technology as the orchestration layer or the settlement layer for payments and things like that, the user of the technology is not really a blockchain user. So before AT&T, they also had T-Mobile. So T-Mobile, I think, it's like a year plus ago that they added T-Mobile support. So they've been building these bridges into what you'd think of as a traditional telecom ecosystem, which I think is interesting. And it was sort of the way we approach things at Beamable as well, which is we knew that we wanted to use a Web3 architecture essentially for running the network, but we didn't want game studios who are the users of the compute on the network, and especially the players of those games, to have to know anything about blockchain, because it in our view, it just shouldn't be required. Like there's all kinds of games.
It's so much extra work.
Yeah, and only a small percentage of games are Web3 games anyway. So, and even at the studio level, like people just don't want to think about blockchain. So we abstract away a lot of the blockchain or all the blockchain stuff as far as the studio is concerned. I'm curious how you think about that as well, because a lot of your structure is around this token economy for the agents and the problem solving. Have you thought about sort of the relationship of that kind of economic structure with onboarding like massive amounts of users and compute, and what do people think of and stuff?
There's a few layers to the flywheel with these things. I think we like to say that like it's very similar to Uber or Airbnb, whereas you get more providers, then the cost goes down, which attracts more supply or more demand, and then that demand coming in actually attracts more supply. We've kind of gone through this cycle a couple times at Koii, and what we're working on now is actually onboarding full communities as a whole. Because we find then what we actually get is we get demand and supply. And if we can get a community that already has like a significant amount of need for compute, then they also can actually come and provide that compute as well. We just end up being the protocol that connects the two pieces. That I think gives people a little bit of a cleaner experience. And I think, like you're saying, they shouldn't know that there's any Web3 involved. It's just I'm using an app, and if I have this other app on my computer, then I can now provide for that network, and I get to use the app for free. Or I get to use the app at a much lower cost, or I get some kind of a special badge, like something like that. And I think we're just mostly at this point where we want to incentivize people to use these systems, but we don't want to make it too difficult. If you have to buy a token and stake the token, there's all these extra steps. It gets very complicated.
Yeah, exactly. So what's next for you guys? You
showed I have one
great stuff that already works.
One last slide here, which is Guerrilla versus Gorilla. This is where we've been going in this. I gave this talk a few weeks ago at the Internet Archive. I called it Guerrilla Internet, Tactics for a Peer-to-Peer Revolution. The whole idea here is Bored Apes and that kind of a vibe has really been the degen mentality for the last couple of years. And I think that the way the world is going right now, whether you really care about the political landscape, the artificial intelligence technology field is accelerating so quickly that we're going to have a moment where we have a possibility of monopolies again. I think this is probably the highest concentration that we've ever seen. They say the economy goes through a phase of bundling and unbundling. So bundling means, there's a bunch of buyouts. Everything ends up as part of the meta stack. You use the same login for your WhatsApp, your Instagram, and your Facebook. That's bundling. Unbundling is usually what happens as the market kind of accelerates and a bunch of those companies are forced to split off by antitrust and things like that. Or what we see is usually that a new technology comes out and it creates a lot of competitors to existing paradigms. The scary thing right now is we're seeing both of those things at the same time. So we're seeing bundling happening where all the companies that used to use AI are now switching over to using ChatGPT or another AI provider. And so everybody's standardizing to these common rails, but those common rails run on a private API. And so that means that as they go and disrupt industries, like as we build up all of these AI-enabled businesses, we're actually sending all of that revenue stream back up to these big companies. And that's why ChatGPT was able to raise, I think, $400 billion in their latest funding round, which is an obscene amount of money. I mean, even considering that is crazy. I think that's more than Canada spends per year, which is nuts. So I think if you think about it that way and you really appreciate the depth of this problem, we're looking for kind of a very peer-to-peer revolution-oriented group of people who are going to take on being the Boston Tea Party moment of this industry. And I think we need to get to this point where we really embrace the fact that we want the free market to prosper and that we want this technology to exist enough to make the sacrifices for it to survive. And so last week we threw a tea bag into the San Francisco harbor.
Nice. So in this whole bundling, unbundling, centralized, decentralized view of the world, when you're thinking about these monopolies, I'm assuming you're thinking about companies like OpenAI with things like ChatGPT, who can concentrate so much of the AI power within one API, essentially, that you then need to use. The interesting observation, though, is like this market ended up being a lot more competitive, a lot faster than I thought. Like it isn't actually just OpenAI, it's OpenAI and Claude and Grok, and a whole bunch of people are out there doing this. And I remember the narrative a couple of years ago was the real value was going to be in the LLM, and everybody else was just like wrapping an LLM in their application. It isn't. My observation is it isn't as simple as that. Actually, like a lot of the time, the LLM is the commodity component, and you swap out the LLM as it gets better. And actually, that's really great for people who are building applications who utilize LLMs, because you can very seamlessly just upgrade, even between completely different companies, supplying the LLM logic into your application, just kind of as you are there and your agents, because your agents are organized around different API keys for the different LLMs, and people could choose one versus another to get at that optimization of right answer for the right price kind of thing. What's just your thoughts on sort of like where the value is being created in this stack? And if we think about this monopolization problem, where do you think that monopolization is happening? Is there going to be an LLM that's eventually so runaway, much more powerful that it's just the only one people want to use, or is it going to continue to be competitive? So kind of that was a big generative question, actually.
Right,
that
I hear you. I hear you.
run with.
I think so. There's two things that happened. I think DeepSeek is a really good example of what can happen in this industry. So DeepSeek was distilled. So what distilled means is someone asked DeepSeek enough questions, or someone at DeepSeek asked ChatGPT enough questions that they were able to simulate ChatGPT based on all the answers to those questions. And actually, interestingly, what happened is DeepSeek is also more efficient than ChatGPT because it got to learn from a master. And you can kind of think of this like, I don't know, Luke Skywalker learns from Obi-Wan Kenobi, right? So Luke's going to be better at stuff because he's younger and more fit, and he learned all of what Obi-Wan knew. And Obi-Wan was better at stuff because he learned it all from Yoda, right? And so Yoda is this old guy who knows everything, but is, a little tired, right? Which is reasonable because he trained all of these people. But as you go down the stack, eventually you do get to something much more powerful. I think what we're seeing, though, is we're seeing a lot of hypocrisy at the very large LLMs. So especially like OpenAI is simultaneously saying, you can't distill us. That's evil. You should go to jail. Let's declare war on China, right? They're saying that. And then they're also at the same time saying, you can't stop us from crawling the internet and stealing everyone's intellectual property. And I think the fact that they can say both of those things in the same sentence is just crazy. And I think that's kind of what we're up against. And that's what we're at war with. So what we've been trying to do by creating this like multi-agent marketplace where we've got a lot of different agents competing to solve coding problems, what we're actually building is the .kno database, which is an open standard that we've created. It's .kno for .knowledge. It's just a little bit shorter, it's cleaner. The .knowledge standard, though, is designed to provide a common ground for these LLMs to actually talk to each other, and it creates that common vector store. And so when you look at one of these repos that we've worked on, there's actually this common thing that all of the different LLMs are contributing to. And we're not distilling the information. We're not trying to copy the LLMs or steal their tech, though I guess we could, realistically. I imagine someone else might do that. But what we're trying to do is to create a common ground so that when you build a product, you're actually building a product that can be used by all these different products. So then it does commoditize the back-end infrastructure. And so then you can actually switch between them, which I think if we don't do that and quickly, we're going to see a world where all of the training data goes back to a couple of large LLMs. And there is a tipping point there where if ChatGPT does get all the training data and they can successfully prevent anybody else from distilling them, then they will have the only copy of like what we would call the embedding of reality, which is kind of like they have that vector database that actually maps all of the human concepts together, and they would probably have the only one, which is why they got all this funding.
All right. Well, it's going to be an interesting next couple of years here while people do get out over this stuff. I want to give you the last word here, Al. This has been an absolutely fascinating conversation. We've covered AI agents, decentralization, agents competing with each other for token rewards to solve problems. I really see this changing the way a lot of industries are going to run in the coming years, and that it'll be humans side by side. At least in this era, we're not quite replacing ourselves with the AI yet, but AI working side by side with humans to solve really tricky problems and super accelerate our productivity. Like your example you gave of like you did 2 weeks of work in 2 hours. Like we're going to see more and more of that, and the value of our time is just going to increase exponentially. Hopefully then we get to go and do whatever we want with the rest of our time. But Al, kind of close things out here. Like what thoughts do you want to leave people with as they think about Koii, AI agents, the future?
So I have a hopeful example about funeral homes. This fellow that I met recently at a conference, we've become friends. He runs a company where they do marketing and they coordinate finding a funeral home, which is a difficult time in people's lives. Funeral homes have traditionally not done marketing, and they're also traditionally and commonly run by much older people. And so typically they're not super web savvy. They don't really understand like Google Ads or any of that kind of stuff, and they don't have a good way of targeting their consumers. At the same time, there's a huge amount of data out there that allows you to identify people who need a funeral home. It's actually very straightforward to find them through like ads monitoring and things like that. And so at this difficult time in people's lives, they need a funeral home. They can be found and they can be identified and given very easy contact, and that whole process can be streamlined considerably. So this guy's been able to spin up a business where he gets referral kickbacks from funeral homes for sending them business by connecting them with customers that actually need their service. And this whole process he was able to set up completely with vibe coding, and it's now a business that serves, I think, over 500 funeral homes around the world. So he's able to be there for people in a moment when they actually really need the help and when they don't want to think about it too much. They don't want to be like calling 20 different phone numbers. And he solves that whole problem for them. And he vibe coded this entire thing, set the whole thing up on an agent flow. And I think it takes him about 2 hours a day to run the business. And those are the kind of opportunities that are out there where you can actually streamline society in a considerable way. It doesn't take being a PhD tech guy. It doesn't take any of that stuff. It's just about coordinating resources. And then the final hopeful note that I have is I think there's hundreds of millions of opportunities like this around the world. And I think we can crowdsource the solutions for them, which means that all you kind of need to do is be part of the DePIN. And then you can kind of actually help with all these things, which is a little bit of a product sales pitch, but mostly I'm just very hopeful about this stuff, which is why I've spent like the last 8 years working on this. We're really, I think at Koii, we're very motivated by the impact that these kind of technologies have. I'm from a pretty small town in Canada, and growing up, I watched probably all the smartest people that I knew leave to go like live in Silicon Valley or live in New York or one of these places. And I think that this is going to spur a transition of global to local, where the local relationships and the local context is actually going to drive how we use large language models and AI. There's a big potential that it can help pretty much everybody, which is really inspiring. So hopefully some people are inspired by this. If you are, we're on Twitter on Koii Foundation, or you can get us on Koii.network. And we also have PrometheusSwarm.ai, which is available. It's Prometheus like pro me and the us, which is our goal. So we want things to be pro you, but also that lead to the us that we all get to live in together.
All right. Thanks, Al. That was absolutely fascinating. Go check out Koii.network. And just if you're coming up to speed on DePIN generally, this is just another example of what a decentralized physical infrastructure network, that's what DePIN stands for, is capable of doing, just distributing or decentralizing, as we just discussed, a lot of resources to scale up compute and solve problems in much more economic ways, but ultimately democratizing a lot of the problem solving so that you can allow more people to participate in the worldwide ecosystem of technology. So that's super cool. I want to thank you for joining me, Al. I want to thank everybody who showed up for this talk. We got nearly 600 people watching. Next time, if you're watching this on a replay, which is probably 95, 98% of you, stop by when we're live, ask a question. We love to have the engagement from the audience like we had from a couple of folks today. Makes it a little bit riskier, but a lot more fun as well to have those conversations. So again, Al, thanks for being here. This has been a blast. Until next time, everybody, take care.
Thanks.